Hello everybody, welcome back. And here's an algebra item on speed, distance, and time. Credits to the Art of Problem Solving community for this item. Suppose school is 2 miles away from my home. Most of the time, I walk to school at a constant speed of 4 miles per hour, but today I walked the first 4/5 of a mile at an average speed of only 2 miles per hour due to severe flooding. If I want to arrive at school on time today, what must my average speed be in miles per hour when I run the final 6/5 miles? Note that I always leave my home at the same time every day. As usual, give this problem a try, and if you're done, let us dive into the solution. So let's talk about the basic relationship between speed, distance, and time. I hope everybody is familiar that we have speed is equal to the distance over the time. And we can use that in the givens because we have the speed I walk at a constant to school, the 4 miles per hour here, that covers the entire 2 miles. So I can say that on a typical day, I will take a total, so we're going to solve for the time. Since we have the speed is equal to the distance over time, speed equals distance over time, we can solve for t simply by rearranging the terms and solving for t. So we can get that t is equal to d over s. So this is the formula used in this equation. So the distance taken, which is 2 miles, over my average speed, so the constant speed I take every day. So 2 miles over 4 miles per hour, so it's going to take me 1/2 hours. So on a typical day, I'm going to take 1/2 of an hour to school. But today, there is a different scenario because for the first 4/5 of a mile and the last 6/5 of a mile, I take different speeds. So to be on time, which is my agenda, I should take a total of 1/2 hour from my home to school, since this is the amount of time that I'm going to take on a typical day. We are given that in the first 4/5 of a mile, I have a speed which is 2 miles per hour. And now the question asks for what speed should I run in my last 6/5 of a mile journey. So let's call it x. So using the same formula, the time is equal to the distance over speed. So in my first 4/5 of a mile, I'm going to take 4/5 miles over 2 miles an hour. So since this is distance taken, the speed is 2 miles per hour. Simplifying, we're going to get that I'm going to take 2/5 of an hour in the first 4.4/5 of a mile. And in the last 6/5 of a mile, I don't know the speed. In fact, this is the value that we want to get. So same formula, the distance 6/5 miles divided by the unknown speed, x miles per hour. So we can simplify this to be 6 over 5x hours. So we have these two times in the first and the last parts of the journey. Now, since this is the time taken, if I add them, this should equal 1/2 because I want to be at school on time. Therefore, we now need to solve for x in the equation 2/5 from the 2/5 of an hour plus 6 over 5x from 6 over 5x hours in this part, and this should equal 1/2. So this is just simple algebra, and we can do it by the following. Let us multiply both sides of the equation by the GCD of the terms. So we take the GCD of the denominators. It's going to be 10x. So let's multiply 10x both sides. So 10x, we can distribute 10x to 2/5 and 6 over 5x. So 10x times 2/5, that will give us 4x. 10x times 6 over 5x, this is going to give us 12. And 1/2 times 10x, this will give us 5x. So this is the result. And all we have to do is to subtract 4x on both sides. Subtract 4x from both sides. And we're going to get that x equals 12. After getting 12, note that the value of x is what we need, so we can finally conclude that I will have to run the last 6/5 miles at a speed of 12 miles per hour. And 12 miles per hour will be our final answer.